Before commencing any work on a vehicle, make sure it is stable and properly supported. It is important that all relevant protective clothing is worn and care is taken when cleaning the brake components so as not to inhale any loose brake dust. If any component needs replacing, use only genuine Arvin Meritor replacement parts to guarantee service life and comply with warranty conditions. This animated sequence demonstrates the operation of the ELSA 225 disc brake, the very latest development in air disc brake technology. The operation of all the disc brakes in the ELSA range is identical. The brakes feature a reaction beam caliper. The brake is actuated by pressure applied by a pneumatic air cylinder. The push rod from the air cylinder is connected to the operation shaft by the ball end of the push rod seating in a pocket in the operation shaft. The operation shaft is machined with an eccentric cam action, which transfers the brake load to the rotor. The pistons that apply the load to the pad backplate have two parts, a trilobal piston and a threaded tappet. The threaded tappet turns and pushes the pistons out as the pad wears. This is done via an adjuster mechanism that is situated between the piston assemblies. The adjuster consists of a yoke, adjuster stem, bearings, an intermediate gear wheel, a barrel, a wrap spring, a system of clutches, a drive cup which is pressed onto the splines of the adjuster stem, a thrust bearing, and a compression spring. The drive cup and the yoke are connected at all times. When the operation shaft turns, the yoke rotates, driving via the adjuster stem and drive cup through the clutches and the wrap spring, delivering torque to the intermediate wheel. When the clamp load is generated, the tappet and pistons become thread-locked, thus increasing the torque required to turn the intermediate wheel. The operating shaft is continuing to increase clamp load, thus still driving the yoke and drive cup. The wrap spring still grips the barrel and the intermediate wheel. Therefore, the clutches begin to slip at a predetermined load to prevent damage to the adjuster components. Trilobal pistons have secondary and primary sealing systems. This allows the brake to continue to function in the unlikelihood of damage to the primary seals. The visual pad wear indicator shows the percentage of wear. Manual de-adjustment of the brake is performed via the manual override stem. By de-adjusting the brake, the pistons are wound back in, allowing the worn pads to be removed and new pads fitted. The brake should be manually adjusted so the pads contact the rotor, and then backed off a half turn, so there is a clearance of approximately 1 millimeter between rotor and pads. The entire brake housing floats on two guide sleeves, thus giving the name a reaction beam caliper. De-adjust the brake by winding the adjuster until there is an increase in effort to turn the wrench. Then turn the adjuster a quarter of a turn in the opposite direction to prevent the mechanism from being locked. Remove the pad retaining strap screw. Lift away the strap. Lift the pads out of the caliper. Check the caliper for wear. Pull the caliper up and down to check for excess play. Push the caliper forward and back to check that the guide sleeve dust excluders create a vacuum and collapse onto the guide sleeve. If it is suspected that there is excessive play, use a magnetic dial test indicator to check the caliper is within permitted tolerances. Check the piston dust excluders for any damage. Check all the way around the front of the dust excluder. Pull the dust excluder forward and check the rear for damage. If the piston dust excluder is damaged, remove it by pulling it off the housing retainer at the back. Then pull the cover off the front retainer and over the piston head. After adjusting the brake to expose the piston, inspect for any damage or pitting caused by water ingress. If the piston is in good condition, refit new dust excluders. Pull the excluder over the head of the piston and fit the excluder bead into the retainer groove on the back of the piston head. Fit the excluder on the housing retainer, ensuring it fits all the way around. Check to see the bead face with the nipples on is seated against the rear face of the retainer groove, and that the nipples are not trapped in the bottom of the retainer groove or facing out of the retainer to ensure the cover is correctly fitted. De-adjust the brake, expelling the air as it becomes trapped in the piston dust excluders by pulling the tabs. Inspect the rotor for wear or any damage. Check the edge for a lip. If there is a noticeable lip, it should be removed, provided the rotor is still above the minimum recommended thickness. Check the rotor faces for crazing, uneven wear and blue spots. If found, the rotor will need replacing. From the replacement pad kit, place the new pads into the caliper and attach new pad springs, making sure the friction material is facing the rotor. Replace the pad retaining strap, ensuring it is located correctly in the caliper housing. Fit the new screw from the kit. Tighten the screw to between 33 to 40 Newton meters. The brake should be manually adjusted so the pads contact the rotor and then backed off a half turn so there is a clearance of approximately 1 millimeter between rotor and pads. Apply a smear of grease to the adjuster, then replace the cover. This completes the pad replacement and brake inspection procedure. Remove the spring brake actuator by unscrewing the two retaining nuts. Unscrew the 4 Torx head screws to remove the caliper bridge. Pull the dust excluders off the retainers. Then slide the caliper housing off the guide sleeves. Using a drift, tap out the two guide sleeve end caps. Before removing the oval brass bush, it is important to mark a reference point to allow proper alignment for the replacement of the bush. Transfer the position of the two notches in the bush to the housing. Scribe a line to mark the center of the notch. Use the arbor from the bush replacement tool to drift out the brass bush, ensuring that the bush is drifted out from the piston side of the housing. From the opposite side, then drift out the retainer. Then for the plain guide sleeve bush bore, drift out the retainer first. Followed by the two plain bushes. Refit the new oval brass bush. Make sure of careful alignment of the notches in the bush with the marks that were previously made in the housing. Using the bush replacement tool, wind in the bush until it stops. Check to see that the notches are correctly aligned. Refit a new retainer. Pay attention to ensure that the retainer is installed parallel to the housing. Wind in the retainer. Check to see there is a 5mm wide groove for fitment of the guide sleeve dust excluder bead. Fit the new metal bushes. Wind in the first bush. The bush should be fitted 1mm below the top of the chamfer in the guide sleeve bore. Turn the housing over and fit the second metal bush. The bush should be pressed into a depth of 7.5mm from the top of the bore. Fit the new retainer, again leaving a 5mm wide groove, as with the previous retainer fitment. Check the condition of the guide sleeves. Look for any scoring or pitting. If it is necessary, replace the guide sleeves by unscrewing the guide sleeve screws. If the brake carrier needs replacing, remove the 4 brake mounting screws. To refit the carrier, use the 4 new brake mounting screws and tighten to between 380 to 420 Newton meters. Fit the new long and short guide sleeves. Tighten to between 430 to 450 Newton meters. Using only the grease supplied in the service kit, grease both guide sleeves, making sure they're well covered. Grease the inside of both the top and bottom metal bushes. Grease the inside of the brass bush. Fit new dust excluders to the retainer on the guide sleeves. Refit the caliper housing, ensuring that both dust excluders are fitted onto the retainers. Fit new guide sleeve end caps. Check to see they are fitted parallel to the housing and that the end cap fitted to the long guide sleeve bore protrudes 6 mm out of the bore. And the end cap for the short guide sleeve bore protrudes 2 mm out of the bore. Refit the caliper bridge. Tighten the 4 new Torx head screws to between 200 and 240 Newton meters. Check to see that a vacuum is formed in the dust excluders by sliding the caliper back and forth. For further information, please contact the Meritor In-Service Reliability Department.